Hi friends, welcome back to my channel. Today I am going to discuss electronics. Some basic topics of electronics which is hinted in hsst exam. I don't go through detail. I just go through the main topics. Okay. Without any delay, let's start. The first topic is semiconductor. How can we classify materials? We can classify materials, conductors, insulators and semiconductors. How we classify these materials? Based upon the band gap energy. Band gap energy. If the band gap energy is higher, then it is insulator. If the band gap energy is lower, then it is semiconductor. If the conduction band and valence band overlaps, then it is a conductor. Next, the term is Fermi level. What do you mean by Fermi level? Fermi level is the highest energy level an electron can occupy in valence band at 0 Kelvin. That is known as Fermi level. Highest energy level an electron can occupy in valence band at 0 Kelvin. That is called Fermi level. Next is the classification of semiconductors. We can classify semiconductors based upon doping and based upon electron momentum. Based upon doping, we all know intrinsic semiconductors and extrinsic semiconductors. Based upon electron momentum, direct band gap semiconductors and indirect band gap semiconductors. We can classify like that. What is intrinsic semiconductors? If there is no doping occurs, then it is called intrinsic semiconductors. If we add some impurities to the semiconductors, then it is called extrinsic semiconductors. What is the direct band gap semiconductor? Direct band gap semiconductor, the electron momentum of conduction band and valence band are same. If the electron momentum of the conduction band and valence band are same, then it is called direct band gap semiconductors. Then what is indirect band gap semiconductors? The electron momentum of conduction band and valence band are different, then it is called indirect band gap semiconductors. Extrinsic semiconductors, we can classify it as p-type and n-type. So then what is p-type? P-type means the holes are majority carriers and we add trivalent impurities. Trivalent impurities to the semiconductors to make p-type semiconductors. Example, gallium, aluminium, barium and indium. Then what is n-type semiconductors? We add pentavalent impurities to make n-type semiconductors. Here the majority charge carriers are electrons, antimony, arsenic, phosphorus. Next is property of semiconductors. What are the properties of semiconductors? First we consider resistivity. If you classify materials according to the resistivity, semiconductor comes in between conductor and insulator. That is, the resistivity of conductor is less than that of semiconductor and resistivity of insulator is greater than that of semiconductor. Zero resistivity for conductors. Next is they have crystalline structure. Semiconductors have crystalline structure and semiconductors formed by covalent bonds. And the main important point is they have negative temperature coefficient. Negative temperature coefficient. What do you mean by negative temperature coefficient? When the temperature increases, resistivity decreases. Temperature increases, resistivity decreases. That is what is called a negative temperature coefficient. Next is p-n junction. What is p-n junction? It is the junction formed by a p-type semiconductor and an n-type semiconductor. P-type semiconductor and n-type semiconductor. How a p-n junction is formed? There are two processes to form a p-n junction. One is diffusion and other is drifting. First, we consider about diffusion. This is a p-type and n-type. We know that the majority carriers in the p-type is holes and majority carriers in the n-type is electrons. Okay. When p-type and n-type comes together due to attraction, p-types, the holes in the p side attracts by the electrons in the n side and comes here. In the same way, electrons in the n side attracts by the p side and comes here. This is known as diffusion. This is known as diffusion. This is the depletion region or space charge region. Depletion region or space charge region. There is no free charge carriers. There is no free charge carriers in the depletion region. Okay, then we are going to discuss what is drift. What is drift? This is the p-type and this is the n-type. We know that due to diffusion, positive charge comes to the n side and negative comes to the p side. Okay, due to the diffusion, depletion region occurs. So an electric field occurs. Due to this electric field, holes at the n side tends to move to the p side and electrons at the p sides tends to move to the n side. So due to the electric field, there is a motion of charge carriers. So this movement is known as drift. This movement is known as drift. So, due to drift and diffusion, a p-n junction is formed. There are two types of biasing, forward biasing and reverse biasing. We are considering the forward biasing, that is, positive is connected to the p side and negative is connected to the n side. When a p-n junction is in forward bias, depletion region decreases. This depletion region decreases. Okay, so we should consider the properties of forward bias. But the width of the depletion region decreases. Okay, if we increase the voltage, number of charge carriers also increases. The conduction in this p-n junction due to the forward bias is due to the majority charge carriers. This junction offers low resistance. That is. Next is reverse biasing. That is, p region is connected by negative and n region is connected by positive. Here, the properties of reverse biasing. The width of the depletion region increases. Conduction is due to the minority charge carriers. Current is voltage independent. The current is independent of voltage. Next is the characteristics of p-n junction diode. Here it is I0 in milliampere. This is the reverse current. This is the forward voltage. So we can consider this is the forward region and this is the reverse region. Okay. We are drawing the characteristics like this. Okay. This is the knee voltage. Or threshold voltage. threshold voltage or cutoff voltage. This region is the leakage current. This is the breakdown region. Breakdown voltage, that is, this is the breakdown voltage. This is the breakdown voltage. Okay, this is the reverse voltage. You may become little confused because this is not that much clear. Okay, I will explain again. This is the characteristics of PN junction diode. This is the forward region and this is the reverse region. This is the new voltage. This is in y-axis we mention current and x-axis we mention voltage. This is the new voltage. Okay, this is the reverse voltage and this is the leakage current, and this is the, you can see a sharp decrease. So this is the breakdown voltage. Okay, so what is the knee voltage or cutoff voltage or threshold voltage? Maximum forward voltage after which the flow of the current increases. Okay, maximum forward voltage after which the flow of the current increases, that is known as knee voltage. For silicon it is considered as 0.7 volt and for germanium it is considered as 0.3 volt. Okay, from the graph, what is leakage current? What is leakage current? Current that flows through the diode when reverse voltage is applied. It is in the range of microampere. It is due to minority charge carriers. Then what is the value of leakage current? Less than 50 microampere for germanium and 20 microampere for silicon. What is the reverse voltage? What is reverse voltage? The voltage in which diode conducted. Okay, after this reverse voltage the diode does not conduct. The voltage in which the diode conduct. Next is, what is breakdown voltage? What is breakdown voltage? A particular voltage after which diode stop conducting when it is in reverse voltage. Is Zener diode, you know about Zener diode? Zener diode conducts in reverse voltage also. Okay, leakage current is otherwise known as minority carrier current. Minority carrier current. Minority carrier current. In the depletion region there are neutralized charges. Neutralized charges and other charges other than the charges in the depletion region are known as uncovered charges. Uncovered charges. Next is, what is diode resistance? There are DC static resistance and AC dynamic resistance. So equation of DC static resistance RD is equal to VD by ID. What is the dynamic resistance? That is RAC, which is equal to eta VT divided by ID. Eta VT divided by ID. The eta is the recombination factor, which is the thermal voltage. ID is the forward current. Okay, that's it for today. Hi friends, all of you study well and stay safe. A couple of videos I uploaded in this channel were concentrated on problematic sections, but last few months I also concentrated on problematic sections other than more than that of theory parts. But I think now it's the time to concentrate on theory parts, because when I go through the questions in the hsst exams, the more are from the theory parts other than that of the problematic section. So although aspirants should focus on the theory sections, especially solid state, electronics, nuclear, everything, you should focus on theory sections, then only we can score. Okay, that's it for today. We can meet in the next video. Tata, bye bye, see you.